The Westminster School are looking at solutions for habitats on Mars.
We are working with Scots School in Australia. Their team involves students from the 3rd and 4th grade, girls from 3rd and 4th grade.
We're working on eco-friendly houses or labs that will be made of mycelium. And mycelium is a kind of fungus. It's a sustainable material, it's very durable and it's cheap and it's very lightweight. It can be transported from Earth and it can be regrown on Mars, so which makes it sustainable. And it also protects us from the environment on Mars, and it protects us from solar radiation.
So Scots School is currently working on a rover, it's known as the Sphere, which can transport the material that we will be building to create a structure in the Martian environment.
The fungus is, of course, very lightweight. It also reflects most of the UV radiation of the sun, any other form of radiation from the background, like the background radiation of space. It reflects that as well, so we are protected from harmful radiation inside when working. It's going to have 3 layers: the outside of frozen ice, which then goes to the bacterium layer. So the water is provided with bacterium, which will then provide food sources for the actual fungus layer, which is going to be the most innermost.
We've done a lot of research and we found out that it can cost a lot to take material from Earth to Mars. So taking material in small amounts can actually help reduce cost greatly. So it will be really cost efficient for us. Well, we plan on taking it in small blocks from Earth to Mars, but then we will be growing it in the Martian environment itself, as it needs a lot of carbon dioxide, and also it's the perfect environment to grow such type of material.
So firstly, the main step was planning. So we planned on, our initial plan was to create a sustainable house. And then second, we sat together and we decided on a design. We chose a dome shape as there's many sandstorms and windstorms in Mars. So it prevents the dust from getting inside, and so the dust slides off. And there's solar panels that will be on the rooftop for its energy source. And there's also an airtight door to keep the area well ventilated. And so this is the side view, this is the top view, and this is the front view.
When we're printing it, we can have like a cross section to show all the parts of the exterior.
Yeah, I think that'll be good. 3 layers.
It takes approximately 24 hours. Right now it's 25% done and there's about 22 hours remaining.
It was time to then consult with partner school in Albury, the Scots School, about how to transport the various components of the new habitat.
The ideas were actually pretty compatible with each other, and we were able to collaborate and allow our works to complement each other. Despite the time differences and all those issues, we were able to come up with many ideas together, and we were able to comment on each other's projects and give constructive criticism on how the project could be improved. We were given some wonderful ideas by the girls from Scots School, and in the end, the whole process helped us improve each other's projects.
We came up with the solution of sending habitats in pieces, and obviously those pieces aren't all going to land in the same spot. So we'd need a rover to go around to collect all the pieces and take them to the one place. So our partner school in Dubai ended up designing a modular habitat that could be 3D printed on the surface of the planet using material from the surface of the planet. Its initial habitat would be sent to Mars for the workers to live in whilst they were 3D printing the other habitats and laboratories.
So the first order of business for the Albury students was to design their rovers.
The kids have found it quite challenging, but they've had a great time along the way. Getting a rover to move across different surfaces was really difficult. They've struggled with friction, surface tension, they've struggled with carrying a load. We had some working prototypes, and then once we added a load onto them, that we had to completely redesign everything and start again. So the students have really had to lean into the design process.
I found really hard that's not going very well for me is I originally had made a rover but it didn't really work, and now I'm just up to rover trying to upgrade it and make it better.
Well, we all have a design that we're liking, and actually nearly all of them can drive on the dance studio floor and in here. So heaps of them can carry like a lot. Some of them can't, but heaps of them can carry like a lot of weight.
The heavier that something gets in your rover, the less far and fast it will go.
They've had a great time working with the students in Dubai. Our initial phone call was only supposed to be half an hour, and we ended up an hour and a half discussing differences in where we lived and the environment that we lived in.
Yeah, I've got a question for you guys. Have you guys seen any kangaroos?
Yes.
Have you guys heard about Burj Khalifa? No? Okay, that is the tallest building in the world, and it's in the UAE, in Dubai.
I heard Australia has a lot of insects like spiders and tarantulas. Is that true?
Yes.
Yeah, we don't have tarantulas, but we actually have scorpions, I've seen them.
The Zoom meetings continued as the students in both countries shared their ideas.
So we've been designing our rovers and testing them. Can I get someone to tell where are we up to with our testing? Okay, just quickly.
We tested them on different surfaces and see how much weight they can carry.
Okay, Jazz, how did we do that?
We built them out of boxes and things, and we put our rovers somewhere in it and put little yellow foam balls in them.
So the foam balls we used as the weights?
Yes.
Okay, anyone else? What else have we done? Annabelle?
If it can't carry some of the weight, like we're sort of going to change some bits. Like when we tested one foam ball, it could go all right, but then 2 a bit slower, and then 3 it could hardly move.
Yeah, so we found that making a car with wheels was quite difficult, and especially making it out of recycled materials. So what have we all gone with? Jazz?
We've all gone with moving sleighs.
So we've made more of a sled type arrangement, so it just drags along the ground. So we found on some surfaces like carpet there was a lot of friction and they wouldn't move. And then what happened with yours, Georgia?
Mine was too heavy and same with Lola's.
And Lola's was too heavy. And what happened when we changed surface, when we put it on the dance floor?
It went fast.
They've learned not to give up. Initially, I had quite a few students say, "Oh, it's too hard, we can't do it."
That you need like something to balance the rover out, because if you like turn, it would usually tip over. Maybe to get things right, you have to keep trial and error. Never give up. Keep on trying.
Another thing they've learned is teamwork.
Keep trying, and if something's difficult, then you can work through it or ask somebody. 3D, like we need to 3D print little parts. We talk together at school, and we're gonna like put them, like try to carry them around space. So we have 5 or 6 working robots, all different designs. We can carry 100 grams.
Okay.
The strongest one can carry 100 grams, and we're now just waiting for the 3D printed habitat to come, and then we'll redesign our rovers if we have to.
We need to upgrade our rovers to hold less weight and go on different surfaces. We need to make sure that they can hold the amount of cargo that we want them to.
Meanwhile, in Dubai, the Westminster School is refining the habitat.
Our idea of using mycelium as a material for building, it's like very sustainable. It does not give out, it reduces carbon emissions, right? It can be applied here, it can be applied in outer space. It's so just for housing in the future. It can also be used for like street lighting, because light pollution is like a real issue as well. Furthermore, we can also use it for taking out like minerals from like wastewater, and the spheros can be used to move things around remotely from like far away places on here on Earth as well. So you don't need a lot of labor for it, reduces labor costs.
Back in Albury, Australia, the students are refining their rovers.
I reckon our Sphero, it's going well. The Sphero can carry our rover fine.
I reckon it's just it lifts off at the back a little, but that's fine because when we put the cargo in, it'll sort of weigh it down a bit.
And we did a bit of trial and error.
Our next step is maybe to go to box number 3,
And hopefully we can do that. And then we can get to number 4 and then we can fuse it.
Awesome.
Because we need about the same code for each one, but just tweak it. Yeah.
Could it carry all the weight?
Yes.
Did it go in the direction you wanted it to?
Yes.
Did it always go in the direction you wanted it to?
No.
So we need to change the code a little bit?
Yeah.
Awesome. So even though we picked up all the bits of house and we didn't quite get them where we wanted them to go, would you still say the project was a success?
Yes. Because it went to all the stops and had time for us to load the pieces of the houses on, and it went in the finish line but just didn't go as far as I wanted.
So we nearly got it right.
Yeah.
So with a bit more time and a bit more tinkering, we'd get it right?
Yeah.
Awesome. Would you do this project again if you had the chance?
Yes.
What would you say to any girls that would have a chance to do it?
It is fun, it expands your mind, and it's fun.
And so the students in Albury were able to finally test their rovers using the 3D printed components designed by their counterparts in Dubai.
If you had to make it again, what would you change? Not as many wheels or more wheels? Or just different wheels?
Many, and probably a different design for more stores.
It's such a great opportunity for the girls, not only just to experience something that's outside our school culture and outside the Australian culture, but just to extend them into something they may not have done before. I know a lot of the girls hadn't done coding at all, yet they hadn't had that experience. A few weren't really that interested in space before the project, and now I know all the girls are going home asking mum and dad for robots for Christmas and talking about space and possible jobs in the future.
At the start I had trouble coding, but it's so easy now doing it because we are trying to do on Mars. Our rover's pretending to be on Mars, moving cargo around. Technology is fun and you have to be listening. That you will learn more things about rovers and scientific things.
Working with Huma Naeem from Dubai has been amazing. Just the amount of work and enthusiasm that she's put in. Certainly all the work that her girls did made it easy for me to guide my girls in our project and just made the whole thing much more enjoyable.
We've definitely learned the possibilities of what you can do outside of the Earth and on the other planets, and just knowing more about space in general and about what you can do on Mars.
So I'm glad that we're pushing for more women and girls in the STEM fields because it provides us with more career opportunities and life goals.
This project has really allowed me to explore my passions in the subject.
So now I want to aid in a project which will actually help people research more about the Martian environment so we can actually colonize the area.